Hello, good morning.
Good morning, sir. I can hear you.
Okay, how are you doing?
Fine, sir. Hope your night was good.
Fine, very good. You're welcome. Let's wait for the others. I'm sure they'll join us.
Okay, sir. Okay, sir.
Although some of them are due to travel today. I'm sure they will, I'm sure like once we have like three, we'll start.
Okay, sir.
Another person is coming in. Yeah, that way. Okay. Well,
Morning, sir.
good morning, Edward. How now?
Fine, thank you, sir. How's work, sir?
Fine, we thank God. How are you doing today?
Fine, thank you, sir.
Okay.
Fine, sir.
Emizio. Okay, Emizio, Emmanuel. We can start early today.
Yes, sir.
How are you today?
Morning, sir. I'm fine, sir. How's work, sir?
Fine, we thank God. You're welcome. Who is the person
Thank
that's
you.
around now? No, not Hosanna. There's another person that's not around.
Emmanuel.
Emmanuel. Okay.
Yes, sir.
Okay. Okay. What we are going to do is, and he joined early last week. Well, let me just start. I'll just start, and then what I'm going to do is I'll start, and then whenever he comes online, he would like join us.
Join in. Okay, sir.
But what I'm going to do is I'll just quickly run through what I did last week.
Okay, sir.
Coding. Okay, but before I start, what I will just ask you to do is, I don't know the view you are using. If you are using speaker view, I think that's views, speaker view and gallery view. If you move to the top right corner of your window, if you are using your system anyway, which I expect you to be using, you will see an icon there. Once you move over a view, click on the view and ensure it's on speaker view. So once you have set it to speaker view, then go to my own window, wherever you see my window, whether as a miniature or whatever, you will right click on that my window and pin. You right click on that my window and then just select pin. Once you right click and pin my window, it means that my screen will not leave you. Why I want you to pin my window is because I'll be sharing my screen when I'm explaining the coding. So it's better you pin my screen so that it will not be going off. Okay, having said that, let me just quickly do a recap. Last week we started this course. It's basically introduction to programming. I'm not actually teaching you Python as a whole. Rather, I want to introduce you to the concept of programming using Python so that subsequently you can be able to easily work with Python. That is actually what I want to achieve with this course. So that subsequently when it comes to programming, you understand what we mean by software development. That is the whole objective of the course. So we'll go to an extent, we'll learn to an extent, but we might not bother to dive so much into all the capabilities of Python as a programming language. I also did some introduction. Hosanna, you are welcome.
Good morning, sir.
Yeah, you're welcome. So I tried to just explain that some concepts of programming we talked about. Did I define programming? Well, in my language, all the definitions were in my language. Programming basically set of instructions that instruct the set of instructions on which the computer functions, or that tells computers what to do. A program is basically a collection of, a software is a collection of many programs that are related. A program is a collection of many instructions that are related. For instance, programs are basically mutually specific. For instance, you can have a program to add any two numbers. When you are to write a program, you need to have an algorithm. I emphasize that it's important for you to understand how to come up with algorithm. I gave example that if you are having a program to add two numbers, for instance, you first of all need to have the first number, the second number, add the two numbers and store it inside the third number, and then display the third number. Then I also told you basically that after that algorithm, which is a step-by-step representation of the processes that you need to take in a program, while flowchart is a diagrammatical representation of your algorithm. Finally, we ended by, I explained to you that majorly, your program is, as a programmer, you have to think from the realm of IPO. Majorly, every program is just IPO. I is what are my inputs? P is what processes am I going to engage in? And O is as in what is the output that is being expected. If you can be able to reduce your complexity to this, you'll be able to easily handle your programs. So, and that was where we stopped. We did not write any code that other day, but today I want to start by writing codes. As in, we'll just start by, okay. There's a correction that I want to make the other day, as in, I wrote some, sorry, just a minute. I did something like this the other day. Shares. Yeah. So the other day I was saying system dot out dot print. Oche is there. Good morning, Oche. We didn't wait for you. As in, so we have system.out.println line. So the other day, as in, like I explained, this is actually Java, right? But I made a mistake in the that of C#. C# is system.console.write-line or .write. So there was an error there. So I just said, let me just correct this error before we start our code. Is that okay? Did you remember this? So I hope you are seeing my screen. That's just basically the correction that I have for today. Okay. Okay. So now, welcome, Oche. So let's now start something serious. So today we are starting from this point. You know, we've talked about some basic things. As in, what we want to start with today is programming with Python. Why? Programming with Python. Well, it's 11. So today we will write Python code. Like I said from the beginning, I know that most of you have set up Python on your system. If you've not set up Python, that one will be done whenever you come to the office. I wouldn't be doing Python setup here. As in, but for me, I think I want to use this thing. I'm going to use Visual Studio Code, VS Code, to actually write. So I'm going to create a new file, and then normally, like I told you, as in the other day, we just wrote a simple code, print, and then we say hello world. That's basically the first code that you can have. And then I can save. Normally, Python files are saved as .py. I'm going to save it as lo1.py. And one of the easiest, as in case it doesn't save properly, you can quote it so that it will save properly. So I'm saving it as lo1.py. And I can run, like I can start as in F5 or Control F5. I can start without debugging. That means that I don't want any special code. So if you look at my screen, you can simply see my output, hello world, right? So let me explain this. This is just a simple code. We made a function call to, sorry, please. Just a minute, please. So, hi all. So hope you are hearing me. Please, I need feedback. Are you hearing me?
Yes,
sir.
sir.
Okay, good. Let's shoot. So this is the normal hello world program, and as in you just have print hello world, and then this. Take note of some things, as in there is nothing special about this code. It's just a very straightforward code. It's just to display a simple line, which is hello world. But the first thing you will note is that, so for me to be able to display something, I am going to call this item. We'll talk about it later, but I just want to mention it a little. This item is called function. And I am just putting words here. Hey, but look at my words. I'm actually putting it inside quotation. Why am I putting it inside quotation? Now let's start talking the real class that we want to share today. What we want to now start discussing today is, we'll start by understanding the concept of variables, as we are looking at variables, data type, and maybe operators. Now, I think the easiest way is, I'll tell you what they say as an academically. They tell you that variables are placeholders with which you hold values, and they are registered in memory addresses inside your codes. But let me just make it very simple for you. Right from elementary school, like when you start getting to primary 4, primary 5, they started introducing X equals to A plus B. They started introducing this concept to you, which is like you are now representing things with characters. Now, basically, I'll just tell you that what they are just trying to do is that at every point in time, when you have two values, A and value B, the result will be an X if you operate plus on it. So when you are now given word problems, the word problem will now narrate to you how to get value A and how to get value B. It is when you have been able to identify what should be A and what should be B. That's when you can get your result as X. And at any point in time, they can change it. They can give you X and A. They can give you 2 of the variables to get 3. So that is how you understand mathematics. Now, hey, let's see how computer works. I'll take you back to history of computers. In those days, or not even in those days, let me talk about even now. Basically, computer is a binary, is an electronic machine, right? And every electronic speaks binary language. That is, when you have an electronic device or any device at all, you will see that you can either power that device on or off. That is the big device. We can look at the electric bulb, the switch, as in the light switch, for instance. It is going to be able to exist in either of 2 states. It's either it's going to be on or it's going to be off. So that's where the concept of binary comes in. Now, in computer, we have different kind of gates and all those things, and then we have complicated it. So it is not as simple as the regular on or off that we know. But however, I'm still pushing this point. The same thing goes with storing things inside memory. When you want to, like, computer uses memory. Let's now take it to that point. In those days, people that are programmers write directly to memory. I know that when you started your course, you would have done all these binary arithmetic and all these things. So what happens is this. Every storage of the computer is actually having its own address. Like you have the first bit, you have the first byte of storage, which will have, 8 bits makes a byte. So, and it is representing different things. Like in those days, we had 256 character set, which is called the ASCII code. You can Google the ASCII, American Standard Information Interchange, as in ASCII. So you have, like, your first gate can be 100001, address 10000011, and then that's how it goes till you've occupied the entire memory of the system. So the people that were coding initially will be like, okay, integer, I will start my integer from binary 1000001. And because integer occupies 2 bytes, I will give it 001 and 011. So you have to remember that you are using 1000110, this all through your code anytime you want to like write a program. So you say A should occupy those 2 addresses. And anytime you want to use the value that you have put in those addresses, you have to call the addresses explicitly. Over the years, they realized that this is not realistic. So they started building layers on top of that programming language. And that's how finally today, we have gotten to a point where we can now declare our variables. So when you say A, you are specifying a location inside the memory of the system. And I believe that you understand how the system works. Basically, the way your computer works is very straightforward. You install the operating system on your computer because the operating system is the one that serves as the interpreter between you that speaks a normal human language like English and the computer that speaks machine language. So the operating system is the interpreter, everything that you are doing. Like, for instance, you click on Start, you click on Microsoft Word. The operating system interprets that command and then goes to the address in storage where that word is installed. Carry all the files that Word needs to start up and loads it on top of the memory. Take notes. storage is different from memory. Storage is your hard disk. Memory is RAM. Every time you are working on top of RAM. So everything that is being loaded is just dropped on the RAM. And the process is being controlled by the computer processor. So that's why when you are looking at your system, you are considering your RAM speed, you are considering your processing speed. If you have high processing speed, low RAM, that means that you cannot optimize the power of the processor. If you have high RAM and low processor, you cannot optimize the power of your RAM. So they need to work hand in hand. That's when you'll be able to enjoy your system. So every time the system fetches and loads, it is occupying spaces in the memory. Now, when you are writing your software program, what you are simply doing is that instead of going to name that address and be calling them 1001 to 1011, instead of you to keep on remembering, or 1010 to keep on remembering that address location, you have given that address location a name A. So it now understands that anytime you mention A, you are referring to the value that is stored inside that location A. And anytime you mention B, you are referring to value that is stored in location B. So anytime the program goes to that location A, it expects to see a value when you call it. Or when you assign a value to variable A, it will replace what you have inside A with the new value that you have assigned, except you perform some other operations. So variable basically are just placeholder in which we keep our values. They are descriptive placeholders in which we keep our values within a program. So when you have any arithmetic expression, for instance, you have let's say S equals to UT plus half AT squared. Please don't mind me, as in I'm not using a device that can easily handle. Okay, so let's say S equals to UT plus half AT squared. This is a normal arithmetic or physics expression, mathematics expression. When you want to convert it to computer in a computer language, it means that for you to be able to solve this solution, there must be a provision for S, there must be a provision for U, there must be a provision for T, there must be a provision for A. All these places, you must create places for all these variables inside the computer system for the computer to be able to work on it. So when you now mention it, the computer will now say, okay, you want A. Now the compiler, the Python compiler will now take a part of the memory. From this number 1 to 2, S should stay there. Number 3 to 4, U should stay there. Number 5 to 6, T should stay there, and 7 to 8, A should stay there. Also, the variable, so that is what variable, that's what is meant by variable. So let me ask the class a question now. Is it clear, my explanation of variable, is it clear, or have I made it complex for you? I need your response now.
You're on the right track.
Okay, so you are getting it clearly.
Yes,
Now,
sir.
after variable, I take it to another level. Every variable is of a data type. Like, what do we mean by that? There are variables that are whole numbers alone, which in most programs, they call it integers, right? There are variables that are fractional, or let's say decimal. There are decimal / fraction fraction based. That is what they call float, double, float, decimal. In some languages, they call it, let me just leave it as float decimal. In some languages, they call it double, as in. So if you are expecting a value that is just going to be like 1 or 2 or 3 or 4, then you are looking at integers. However, integers also would be used for calculation. These are numbers that are expected to be used for calculation. The same thing with this, as in you're expecting to use it for calculation. Now, if you're expecting things like 0.1, 5.2, 128.95, if you have to go down the precision lane, then you can think of float, decimal, in some cases double. If you want to go like character, that is single alphabetical value, is what they call character, like A or B or C or D. Those are the kind of value that it holds. Cannot be part of calculation, right? As in, then we have, if you need multiple alphabetical value, that's what they refer to as string, like Ed. Okay. So these are basic data type. Also, you can talk of date. That is date value and years. Then we have characters like after date, we have logs. Large. Okay. So, hold on, where is this date. Okay. Is there any other thing I want to show you here? Okay, let's come back. So these are data types. Now, why data type is important is because the computer needs to understand the size of memory that should be allocated to be able to accept the kind of value that you want to push in. That is majorly what the data type actually helps to do. For instance, for most of the programming languages, 2 bytes can be able to store integer, while this one might be like maybe 4 bytes of memory space. As in large objects, some of them can allocate as much as, how would I say, as in, don't let me make another mistake, but some of them can allocate as much as gigabytes of data for the storage of large objects. So, and it also tells it the kind of activity that can be performed on top of that particular variable or value. So you need to define or clear your variable: integer, float, character, string, date, or date time, blobs, or at times they say blobs or logs, as in that's just a binary large object. That's the meaning of blob, as in, and so on. So as in any other language that you are learning, one of the fundamental things you have to understand is the variables that language supports. Fine. So let me give you an exercise. As in, I want you to respond to this exercise via chat. Which data type should be used to store the value of S?